Welcome back to College Trigonometry. This is Professor Win. Um, I assume that you guys already watched my video, right? Our first lecture video, and hopefully you guys understand it because so far I have not received any concern or question related to the material. If you guys have concern, just post your question on the discussion board, okay? Other than that, we have to keep moving forward. So for the video lecture today, I want to talk about section 6.1. Then the second part of the lecture, which is in the second video, I will be talking about section 6.2, okay? I don't know, 6.1, no, let me see, let me check one more time. It should be, let me see here. I'm sorry, it's about section 7.3, okay? Um, 7.2 and 7.3, I'm sorry. So today I'm talking about section 7.2. And as you already know, the main purpose of trigonometry is to solve triangle. It means that it helps us to find the length or the angle of a triangle. Okay, okay. And at the beginning of the semester, we learned how to do it by using trigonometry ratio. However, trigonometry ratio is just it works for the case when you have right triangle only. Then how about the case when we have uh, arbitrary triangle? When I'm talking about the regular triangle, the oblique triangle. So before I'm talking about that, just write out the topic today. So today we're talking about solving triangle. Okay, and on the first part of the video, I'm talking about the law. Um, Hold on. Let's wait a little bit before I introduce you to this law. So on the first part, let's do a quick recall. Okay. You know that when we talk about regular triangle, we're talking about the oblique triangle. What is oblique triangle? Okay, the triangle that does not have a 90-degree angle is called oblique triangle. Okay, does not have 90-degree angle. Okay, and the oblique triangle, there in the oblique triangle there are two different type. The first type is acute triangle, and another type is obtuse triangle. Okay. Acute triangle is the triangle whose three angle is the acute angle. Obtuse triangle that has one of the angle more than 90 degree. So this is one of the angle is greater than 90 degree. Okay, obtuse triangle, the all three angle are acute triangle. Okay, and we will draw a quick acute triangle right here. So the acute triangle will look like this. Okay, so you see the all three angle here is acute angle, and for the obtuse triangle we're gonna have something like this. See that? So we have one angle is greater than 90 degree. So this one right here, greater than 90 degree, even though that we have two acute triangle here, but one of the angle, acute angle right here, so one of the angle here is more than 90 degrees. So this is obtuse triangle. Okay. The question is, how we're gonna solve this triangle here, given a certain information? What if they give you the side, the length of the side? What if they give you the measure of the angle? Then how we define, how we gonna find the measure and the measure of all the angle and the length of all the side? Okay, so in order to answer that question, um, we need to know what a law of sine is. So on the second part of the lecture, uh, I want to talk about law of sine. Okay, because we cannot use the trigonometry ratio anymore. Okay, because this is not a right triangle. So the law of sine will be used to solve acute triangle or obtuse triangle. Okay, now what is law of sine? The law of sine stated that given arbitrary triangle, okay, ABC, with this is angle alpha, beta, and gamma, and the law of sine stated that sine of sine of alpha, okay, sine of alpha over BC is equal to sine of beta over AC equal to sine of gamma over AB. Okay, so you have to memorize this formula. And remember this, a law of sine only work when you have oblique triangle, okay, which is the acute triangle or obtuse triangle. You shouldn't use this when you have right triangle. Well, it's also work, okay, but I mean, for the right triangle, we just use trigonometry ratio, okay. And in order to apply law of sine in efficiently when you solving triangle, uh, we need to categorize the triangle into three cases. Okay, the first case. Okay, the first case is when we have um, the triangle. When you have a triangle that's given an angle or the side or the angle, so we call that ASA. Or they are given angle side. Okay. It means that the question they give you the question give you the angle, they give you the side, and they give you the angle. Or the question give you the angle, and the side. Then you can apply the law of sine directly. Okay. For example, I give you something like this, and I want you to solve the triangle for me. Okay. How about like this? Example. I give you the triangle. Okay. With this is 75.8 degree, and this is 10.2 inches, and this is 45.1 degree. And I asked you to solve this triangle. Okay. Okay. So we gotta check. We gotta check if it is the question here is fall into the first case or not. Okay, so they give you the angle, they give you the sine, and they give you the angle. So it's satisfied, right? Because over here, angle, sine, angle. You see that? Angle, sine, angle, angle, sine, angle. They are all given. Okay, and they're all given, right? Then we can apply the law of sine directly. Okay, we can apply the law of sine directly without categorize into subcases, because later on that's when you deal with another case, we have to categorize that case into smaller cases, so I call it subcases. Okay. So in this case, angle sine angle is given, then we can apply the law of sine directly. Okay, but before apply the law of sine, you see that we also know that in the triangle, the sum of all angle in the triangle, okay, is 180 degree. So I can find this angle easily, right? So let me call this ABC here. Okay, so I can find angle alpha easily. Angle alpha will be 180 minus 75.8 plus 45.1, because the sum of all interior angle of the any triangle is 180. So they already given you two angles, then we can find the last one, which is give you 59.1 degree. Okay. And now I can find I can find AB and AC applying the law of sine. So how we do that? We have sine of 45, so sine of 45.1 degree over the opposite, right? The opposite of this angle will be AB, okay, equal to what? We already know BC. We already know BC. So BC is 10.2 inches. And we know the angle alpha. We already calculate over here, which is sine of 59.1. Okay. This is also equal to AC, right? On the top, we have sine of 75.8 degree. Okay. So after we plug in all the angle into the law of sine formula, then I can solve the proportion easily. So I just cover this part and I solve for AB here. Then in order to solve for AC, I just cover this part. Then I can solve for AC. Then in order to solve for AB, I cover this part, and this is a proportion, so I do cross multiply. So I will have sine of 59.1 degree times AB equal to 10.2 times sine of 45.1 degree. Then AB equal to 10.2 times sine of 45.1 degree over sine of 59.1 degree. Okay. Okay, then we just need to put into our calculator. Let me put into our calculator. Then it give you what? It should give you 8.42 inches. Okay. Alright, so that is AB. Now I do the same for AC. I cover this part. Then I have the proportion. I do cross multiply over here. So I have AC times sine of 59.1 equal to 10.2 times sine of 75.8. Then AC give you 10.2 sine of 75.8 degree over sine of 59.1 degree. Okay, then from there I can put into our calculator, and I got my AC give you 11.5 inches. Okay. And now I successfully solve this triangle, because we got AC, we got AB, I got BC given, and we got the measure of all three triangles. So you see that if you in the first case, if you in this case a angle sine angle, your job is very easy. Or if you in the case angle sine AAS, your job is also very easy too. Let's say I can give you another example where we have to do um, angle sine. Okay, how about this? Example 2, this is example 1. Let's do the example when we are in angle sine, okay? Angle sine. Okay, angle sine. Example 2. Okay, so I have the triangle like this. Then I have angle is 63 degree. Over here is 38 degree. And they give you this 12 inches. So they give you angle sine. So you see that? So that is ABC here. This is alpha. Alpha, beta, gamma. Now I want to solve the triangle. It means that I have to find angle alpha, I need to find BC, and I need to find AB. So angle alpha is very easy. So alpha is 180 minus the sum of 63 and 38. Okay, which is give you 79. And I can find AC. Oh, AC is given already. I can find BC and AB by just plugging information we already know into the law of sine formula. So we have sine of alpha, sine of 79 over the opposite, which is BC. Okay, alpha over BC equal to sine of 63 over 12 and equal to sine of 38 over AB. Okay, so we need to find BC. I covered this part. You see that? Then I apply law the proportion, cross multiply here. So I have sine 79 degree BC, sine of 63 degree. Then BC equal to 12 sine of 79 degree over sine of 63 degree, and we just give you what? Put into our calculator, and I believe they give you 13 inches. Similarly, I cover this in order to get this proportion. Okay, then I can find AB. So AB sine of 63 degree times AB equal to 12 sine of 38 degree. So I got AB will be 12 sine of 38 degree over sine of 63 degree, which is give you put into a calculator. Yeah, where's my calculator? This is the one I just put over here. Oh, sorry guys. Okay. So what I have here? So I have 38, right? Sine, right? 30 degrees, take sine, times 12, divide by 63 sine. Alright. Oh, I think I'm going to have to do carefully. 38 sine times 12 give you 7.3879 over sine 0.0891. So I have 7.3879 divided by 0.891 give you 8.29 inches. And here you go. We finished calculating the length AB. Okay, then we're done. We're done solving triangle. Okay, so you see that if it in angle sine angle, or angle sine, then we just apply the law of sine directly. Okay. How about when we in the second case? The second case, which is triangle when they are given sine angle. Okay. So if they give you a triangle and they give you the length of 2 sine and an angle, okay, then in this case, this case could be a very hard case right here, because for this case you have to categorize it into 2 subcase. Okay. Oh, I mean a lot of case, not 2 subcase, not just 2 subcase, because we have to calculate the amplitude of that triangle, okay, to see if the angle they given, okay, if the angle they given is the acute angle or obtuse triangle, acute angle or obtuse angle, okay? Because if they acute angle, then we have to even categorize more into smaller subcase. And if it obtuse angle, then we also have to categorize it into 2 smaller case. Okay, let's do this. You will see. Okay. So I give you the example, but I'm not gonna solve it yet because we need to go through the concept first. So the sine angle case, when we have something like this, they give you a triangle and they ask you to solve for this triangle. When they give you this is 34 degree, and they give you this is alpha, and this A, B, C, and they give you B is 2.3 here, and A is 1.2, for example, like that. Okay, probably not in scale. So they give you sine angle, sine angle. Okay, so you cannot read this as sine angle sine. Okay, because for the sine angle sine, okay, the angle must be in between. Okay, but and we didn't even talk about sine angle. We didn't talk about sine angle sine yet. Okay, sine angle sine, we have to use another concept. Well, you can use a lot of sine too to solve for the case sine angle sine, but I will introduce another concept too. Okay, so this case will be sine angle, sine angle, all right? Okay, sine angle. All right. So when you in this case, in this situation, okay, all you have to do is you need to have you need to calculate the amplitude. Okay, so before calculate the amplitude, I just want to put a remark here. Okay, the angle, okay, the angle is given, which is the angle here, must be opposite one of the side. Okay, because if it's not opposite one of the side, then this cannot be considered a side-side angle case. Okay, and again we have several variations we need to consider before we solve this triangle. First of all, we need to calculate the altitude, and the altitude, in order to calculate the altitude, we need to use this formula: h equal to b sine alpha. What is b? What is alpha? So b and alpha is the value and the value of the angle and the side they are given, but alpha and b must be opposite to each other. Okay, must be opposite to each other. So in this case, your alpha is 34, your b is 1/2. Okay, so you need to calculate the h, and after you calculate the h, and you need to consider, then the next step is you have to consider your alpha is acute or obtuse. If your alpha is acute, okay, if your alpha is acute angle, then we have four different cases. We have four different cases. Okay, four different cases. The first case is when a greater than 0 and less than h. Okay, a is the side that opposite alpha. Okay, a is the side that opposite alpha. B is the side I think I said something wrong before, right? So A is the side that opposite alpha, and your B, I'm sorry, B is over here. Your B is the side that adjacent to the angle. Okay, adjacent to the angle. So A is the side that A is the side that opposite alpha. Okay. Then if A is greater than 0 and less than h, then we have one triangle. Okay, we have one triangle. Okay, if A equal h, then we have zero triangle here. Then we have one triangle here. Okay, if A equal h, we have one triangle. If A is less than h greater than 0, we have zero triangle. It means that we don't have any triangle to solve. It means the information they give us is not like it's not there's no way you can solve the triangle with those information. That's what I mean. Okay, if A less than B and greater than h, then we have two triangles. Okay, if A greater than B, then we have one triangle. Okay, with A greater than B, we have one triangle. So you see the in this case I give you A over here, B over here, right? So your A is less than B, so it's not in this case. It's not in this sub case here. Okay. Another case is when you have angle alpha as obtuse angle. Then for this case, we divide it into two subcases, okay, which is A is less when greater than 0, but less than equal to B. Then we have zero triangle. And if A greater than B, we have one triangle. So for when you consider alpha as obtuse angle, we don't have to solve for h anymore. We just look at the A and B, and you will see that how many triangle you will have. Okay. Okay. So this information here is very important, okay, because it helps you to know how many triangle you need to solve. Okay, because sometimes some students just solve one of the triangle and then miss another one. When you guys in the sub case right here, then we have two triangle. Then you have to solve both case, not just one case. Okay. All right. Let me do the example. Okay. Okay. Let's do the example. Let me uh, redraw the triangle I already have at the beginning. So we have 34, A, B, C. This is 1.2, this is 2.3. Okay. Okay, so this is your alpha, this is your B. Okay, this is the opposite of alpha. Okay, then we have to calculate. You know that's your B over here is smaller than your B over here is greater than A. So your B over here is greater than A, and because B is greater than A, then it's not in this case. Okay, because this is A greater than B. Okay, so we have to calculate the h. Well, it doesn't matter. You have to calculate the h first. Okay, unless you have alpha is obtuse triangle, but in this case you see that your alpha is obtuse acute triangle. So alpha equals 34 is acute angle. Okay, and because it's acute angle, then we have to use this. Okay, this is, you have to use this case. Okay, all right, so I'm gonna calculate h. H equal to b sine alpha is equal to, b is the side that adjacent to the angle alpha. Okay, so b is 2.3, alpha is sine 34. Okay, okay. Then you will have 2.3 sine 34, which is give you 34 degree sine, right? Time 2.3, 1.286. Okay. All right. So your h will be what? Your h, you think that your h will be equal to a? Your h equal to a? No, right? Because your a is 1.2 and your h is, oh yeah, kind of, but it's less than. Your a is 1.2. So your a is 1.2 and your h is 1.286, right? So your a less than h is greater than 0. Okay. Okay, your a less than h greater than 0. Okay. Then what? It means what? It means there's no triangle existed. Okay. Okay. No triangle existed. We don't have any triangle. Even though that we can apply the law of sine, but it's not gonna work. Okay, it's not gonna work. Okay, we don't have any triangle. So in that case, you don't need to solve for anything unless they want you to find angle beta, which is maybe you can sine of beta. This is beta right here over 2.3 equal to sine 34 degree over 1.2. I apply the law of sine here, which is you can find the law, you can find beta easily. which is 1.0718. Then beta, you take inverse of that, 1.080718. Take the inverse. You see that? It doesn't work, right? Because sine is greater than 1. And you see that's why b does not exist. You remember the sign between -1 and 1, and this is greater than 1. So when you put into the calculator, it doesn't work. So you see b does not exist. And b does not exist, there's no triangle. Okay, you don't have to do that. Then this is a good way to check. Because as long as you know it's less than h is greater than 0, you know right away that there's no triangle exist. Okay. Let me hold on. Okay. So you see that in this example, we don't have any triangle to solve. Okay, let's do another example. Example 2. Okay. Example 2, when I give you the triangle like this, and I give you an 547, this is 47 degree. I give you this is 3.7. Okay. And I give you this is 3.5. So this A, B, and C again. Okay. Okay. So you see right away, right here is my A is greater than B, right? And my A is greater than B. My A equal 3.7, right? And my B is 3.5. A is the side of opposite angle alpha, and B is the side of opposite angle beta. Angle beta, so angle B right here. So this is B beta, this is gamma. Okay, so my A greater than B, and because my A is greater than B, and this is acute angle 47. So we have only one triangle. And because we have only one triangle, then your job will be easy. You just need to solve whatever you have. You need to solve left. Okay, so this is 47, 33.7, this is 3.5. I apply the law of sine. Then I have sine of 47 over 3.7 equal to sine of beta over 3.5 equal to sine of gamma over something we don't know. I call the C. All right, so this C, which is AB. Okay, so from this proportion here, I cover this, so I can solve for beta. All right, I apply the law, the cross multiply here, so I have 3.5 sine 47 degree equal to 3.7 sine of beta. Then sine of beta equal to 3.5 sine 47 degree over 3.7. Okay, I think I have to use another calculator to solve this. I'll get back to you soon. Okay. Okay, I have to use this. So I have 47 degree. So I have 3.5. Okay, time sine of 47 degree. Okay, okay, over 3.7, and I give you 0.69. Okay, Okay, then you just need to take inverse upon 6918. Let's see it work or not. I have 43.7 degree. Okay, I have 43.7 degree. Oh, there's no internet? Oh, sorry guys, I don't know if it's internet or not, because if it doesn't have internet, then I have to stop the video, because the software, it is the online software. Let me check it really quick here. Okay, so after you solve for beta, it's 43.7 degree. I can solve for gamma, right? Because we already know alpha, so we know the sum of the triangle is 180. So I can solve for gamma. 180 minus 43.7 plus 47 equal 89. And from gamma, I plug into this part, this proportion here, to solve for C value. So beta will be 43.7 over 3.5 equal to sine of 89, okay, over C, okay. And you here, from here I can get C easily is 5.1. Okay, so that is the end of the second example. On the third example, I want to give you the problem when you have to solve two triangles. Okay, and the problem is like this. Okay, example 3. Okay, I have angle alpha is 26 degree, so it's acute, and I is given that A is 11 centimeter, B is 18 centimeter. Okay, so when you draw the triangle, you have to draw carefully over here, okay? Because if you don't draw carefully, you have to scale. You don't have to scale it perfectly, but you have to scale as much as you can, as good as you can. So the 26 degree is kind of like this. Okay, this is 18, so this is 11. Okay, and so this is 26 degree. Okay, okay, so this is your alpha, this is B, yeah, this is your A, this is your B, okay, and this is your C, and this is your gamma. Okay, so first step again, because alpha is 26, is acute, so we have to solve for H. H is B sine. Okay, solution. H is B sine alpha. Okay, H is B sine alpha. So your B is 18 sine alpha, sine 26 equal to 7.89. Okay, so that's your B. That's your B. And now, that's your H. So your H, you see that A less than B is 11, less than 18. However, it's greater than 7.89. So I know that your H is less than A, less than B. And because your H is less than A, less than B, so you see that your H is less than A, less than B. So you have two triangles. Okay, you have two triangles. So and we need to solve the first triangle first. This first triangle is very easy. It's the same thing as you usually do. Triangle 1. Okay, so I'm going to show the first triangle for you. So you have alpha already, so I just need to set up the law of sine. So sine of alpha over 11 equal to sine of beta over 18 equal to sine of gamma over c. So we got alpha already, which is sine of 26 over 11 equal to sine of beta over 18. So from here I can solve for beta, right? So 18 times sine of 26 equal to 11 sine of beta. So sine of beta equal to 18 sine of 26 degree over 11, okay, which is give you 0.7173, and you take the inverse, which is give you 46 degree. And now you got beta, you got alpha, and you can find gamma is 180 minus 46 plus 26, which is gamma is 108. And from here I can solve for c by plug gamma into this part of the portion. So I have sine of 46 over 11 over 18 equal to sine of 108 over c. And from here I can get c by 18 times sine 108 over sine of 46, which is your c 24 centimeter. Okay, so I successfully solved the first triangle, but we need to solve another one because there are two triangles. But where's will be the other one? Okay, triangle 2. So in order to solve for the other triangle, you need to draw the second triangle. How should I draw that? So I know that your beta is 46, so this is 46. Okay, I know this gamma is 108. Okay, the alpha is fixed. Okay, you cannot change it. Okay, alpha is fixed. So this is how you get the second triangle. So you're gonna draw the isosceles that has the base angle 46. So this 46 here, so the isosceles that has the same angle 46, the base angle of the isosceles, okay, you draw the isosceles whose base angle is 46. So it means that 46 here, then the isosceles will be like that, right? So this isosceles. So this is 46. Okay, and because that's a 46, so the new beta angle will be beta prime is this one. Okay, if beta prime is that one, okay, I can find it. So beta prime is be 180, right, minus 46. Because if this is a flat angle, you subtract by 46, give you new beta prime, which is 134. Okay, so your alpha is still fixed. You see that? But gamma prime will be this case now. Gamma prime will be this one. And because the new triangle, this one will be the second triangle. Okay, so the gamma prime will be 180 minus 134 plus 26, which is give you 20 degree. Here you go. Now you got a gamma prime, you got beta prime. I can solve the second triangle easily by applying the law of sine. Sine 26 over 11 equal to, this is 11, okay, because it's isosceles. So this is also 11, so that's why we have sine 26 over 11. Sine of beta prime, 134 over 18. Sine of 20 over c prime. There I can get c prime easily by look at this proportion only. Okay, so c prime sine 134 degree equal to 18 sine 20 degree. So c prime, right, you 8.582 centimeter. All right, so I got everything. Okay, I got a second triangle. I got beta prime, I got gamma prime, alpha is the same already. I got this one 11, this 18, C prime, this is C prime right here. Okay, C prime from here to here. Okay, it's 8.582. So I successfully solved both triangle 1 and triangle 2. So when you have the case of having two triangles, you have to be careful. You have to draw carefully. Okay, then you must be able to draw the second triangle. Okay, based on the angle beta, based on the angle beta. Okay, by drawing the isosceles whose base angle is the same as angle beta. Okay, then from there you can solve both triangle. Okay, so I have to say that solving triangle is not hard, but you need to memorize the rule. You need to memorize this rule, okay, in order to know that if you miss any triangle or not. Okay, so for the case side angle, that's harder. But if the angle, if you in the case um, angle angle side um, angle side or angle triangle, then could be very easy. If you in the case side angle side, it's also easy. In the second part of the lecture video, I will talk about another law. It help you to solve that case. Okay, you can also use the law of sine to solve that case too, but sometimes the law I will be talking about is easier for you to use. Okay, and you can use anywhere. Actually, the law of sine you can use anywhere too. Okay, so again, if you guys have any question, you have to post your question on the discussion board. Okay, then let me know if you don't get any part in this lecture, then I'll try to give you response as soon as I can. Okay, thank you so much, and I'll see you next time.